Good morning and welcome to lecture 24 of NFTL. That is unit 4 of your syllabus, transmission lines. Transmission lines are the conductors used to transmit energy. Transmission line is a conductive method of guiding the electrical signal from one place to another. Transmission lines are used as link between an antenna and a transmitter or receiver. They are also employed as circuit elements like inductors, capacitors, resonant circuits, filters, transformers, and even insulators at very high frequencies. They are also used as measuring devices and an aid to obtain impedance matching. There are basically four types of transmission lines. First one is parallel wire type, second is coaxial type, third is waveguide, fourth is optical fibers, fifth is submarine cables, and sixth one is strip line transmission line. So first is the parallel wire type is a common form of transmission line, also known as open wire line because of its construction. They are commonly employed as telephone lines, telegraphy line, and power line. Short runs of these lines are also used as antenna feeders and impedance matching purpose. They are cheaper and easier to construct. Insulation between the conductors is normally air. Dielectric loss is extremely small. Open wire line is balanced with respect to earth. But there is a significant energy loss due to radiation. As a result, these lines are unusable for frequencies above 100 MHz. Electrical energy propagating through these lines set up electric field between the line conductors. These fields are at right angles to each other. So, and to the direction of propagation, this type of energy transmission is commonly known as transverse electromagnetic mode of propagation. So these are the two parallel conductors running through the transmission line, and this is the electric field which is formed between the two conductors. So this is called electromagnetic field in H field open wire line. Next is coaxial type of cable. In this, one conductor is a hollow tube and the second conductor being located inside and coaxial with the tube. The dielectric may be solid or gaseous. In order to avoid radiation loss in open wire lines at frequency beyond 100 MHz, a closed field configuration is employed. In coaxial cables, by surroundings the inner conductor with an outer cylindrical hollow conductor as shown in figure. Advantages of coaxial is that electric and magnetic field remains confined within the outer conductor and cannot leak into the free space. As a result, the radiation is totally eliminated. Also, the outer conductor also provides a highly effective electromagnetic shielding against external electromagnetic signals. So, this is the diagram of coaxial cable. This is H field, this is E field, this is the diameter of the cable, and this is the diameter of the outer shield. So electromagnetic field and construction details of coaxial cable. Coaxial cables are extensively used for a frequency range up to 1 GHz. Beyond 1 GHz, these cables become unusable. Next is waveguides. A transmission line consisting of suitable shaped hollow conductor which may be filled with a dielectric material and used to guide electromagnetic waves of ultra high frequency or UHF propagated along its length is called waveguide. The transmitted wave is reflected back to the internal walls of the waveguide, and the resulting distribution associated with the wave causes the transmission mode. This mode of electromagnetic wave is governed by the configuration of vector describing the wave. The main type of wave configurations are TE wave or transverse electric wave, TM wave or transverse magnetic wave, TEM wave or transverse electromagnetic wave. TEM is one of the most commonly excited mode in coaxial cables. It cannot be propagated in waveguides. Now, electromagnetic waves may be excited in a waveguide utilizing the electric and magnetic field associated with the electromagnetic wave present in another device, such as cavity resonators or microwave tubes. A suitable connector is used to interconnect the waveguide to the source of radiation in order to achieve the optimum transfer of energy and to excite the desired transfer mode. Waveguides are extensively used in communication for transmission of electromagnetic waves. Now this is the internal diagram of waveguide. Okay, so here this is the outer cladding, this is optical fiber, and this is the core. Inside the core the wave travels like this. So outer cladding, optical fiber, and the core. Now next is optical fibers. Optical fibers offers several important advantages over waveguides like superior transmission quality, high information carrying capacity, light in weight and smaller in size, reduced cost, high security, no EMI effect, immune to electromagnetic radiations, and immune to radio interference. No crosstalk frequency and no effect of weather. By wave division multiplication, the information carrying capacity of the optical fiber can be increased. Optical fiber can be three types: multimode step index, single mode step index, and multimode graded index fiber. Now we can see this is the unit length of transmission line. This is resistance, inductor, capacitor, and conductance. So next is submarine cables. They are also known as ocean cables or transatlantic telephone cables or TAT. These are used for overseas communication. They have been largest means of communication before satellite communication came into being. They are manufactured in the length of 300 km called blocks. They are of two types: telegraph cable, single conductor cable, and telephone cable or coaxial construction with two conductors throughout. So that is called telephone cable. Next is strip line. Strip line is a balanced transmission line. It consists of a rectangular conductor of height h and a width w, symmetrically placed between two ground planes separated by a distance d. It consists of conducting strip embedded in the dielectric medium between the two ground planes. First type of strip line is basic strip line. It is shown here. Second is coupled strip line. So this is even mode coupled strip line. Third is odd mode strip line. It is like this. Now that is all in the lecture today of fundamentals of transmission lines. In the next lecture, we will continue with the electrical circuit parameters associated with transmission lines. Thank you so much for attending my lecture. Keep sharing it with your friends and subscribe my channel.